One powerful AWS server can look safe until one failure takes the whole banking service with it. In the early version, front-end, API, jobs, and maybe the database all share the same machine boundary. That is simple to draw, but it is also one shared blast radius. A larger instance gives more CPU and memory, but it does not create a second place for the service to survive. The bank grade question is not how big the server is. It is which failures the service can tolerate without losing customers, payments, or audit evidence. When the single server disappears, every path through the system disappears with it. Login, balance checks, payment submission, background jobs, and admin tooling. Routine patching also becomes a business event. If there is only one box, maintenance windows turn into customer-facing downtime. Deployments carry the same risk. A bad release on one shared host can damage the whole service instead of one small runtime boundary. A compromise is worse again. One exposed credential, or host, can put multiple application components inside the same attacker reach. The first serious improvement is to stop sending all traffic to one instance. Put the API behind an application load balancer. Run more than one copy of the application and place those copies in separate availability zones, so one zone is not the whole service. Use health checks and auto-scaling to replace unhealthy instances. The system should remove bad capacity and add safe capacity without a manual rescue. This pattern keeps EC2 control, but it also keeps EC2 ownership. Images, patch cycles, scaling policies, session design, and recovery automation. EC2 is still the right answer when the workload genuinely needs machine-level control. Custom agents, licensed software, unusual networking, or a legacy runtime. Legacy banking systems often start here during migration. The goal is not shame. The goal is to put guardrails around the risk while the platform evolves. That means golden images, patch pipelines, configuration management, backups, and repeatable rebuilds are part of the architecture, not optional housekeeping. Choose EC2 when control is the requirement. Do not choose it just because the first prototype was a comfortable server. For most new stateless banking APIs, containers reduce the shared server problem. Each service gets a smaller, clearer runtime boundary. With ECS on Fargate, the team describes the container, CPU, memory, networking, and identity. AWS manages the underlying host layer. The useful design move is separation. Customer API, payment orchestration, fraud integration, and notification services can each carry different IAM permissions. Rolling deployment then changes one task at a time. The service can move forward while healthy tasks keep serving traffic. EKS gives the organization managed Kubernetes control plane behavior and access to the Kubernetes ecosystem, but it does not remove platform responsibility. A real Kubernetes platform includes namespaces, policies, ingress, add-ons, node strategy, image controls, observability, and planned upgrades. That power is valuable when a bank already has Kubernetes standards, many services, complex scheduling needs, or a hybrid platform strategy. Without a mature platform team, Kubernetes can become a risk multiplier, more places to misconfigure, monitor, patch, and debug. Lambda is strongest around short, event-driven work, webhook handling, audit enrichment, notifications, file checks, and scheduled reconciliation triggers. The banking rule is simple. Retries must be safe. A duplicated event must not debit money, send a payment, or create an audit record twice. Concurrency still needs design. Serverless can scale quickly, so downstream databases, APIs, and fraud services need quotas, back pressure, and connection control. Use Lambda around the core, where events are short and isolated. Do not turn every long-running financial workflow into scattered functions. The bank-grade design starts at the edge, Route 53, CloudFront when useful, WF, and the load balancer expose the public path, not the private platform. Behind that edge, critical APIs run as services across multiple availability zones with private networking and health-based routing. The database is independent from the application layer. Use managed multi-AZ database protection and design read scaling separately from high availability. Queues absorb temporary pressure, backups protect recovery, and observability gives engineers the evidence to see failures before customers teach them. So the first decision is failure tolerance. What happens if one server, one zone, one deployment, or one credential fails during a busy banking day? Then match the workload. Use EC2 for machine control, Fargate for straightforward containerized services, EKS for mature Kubernetes platforms, and Lambda for short events. Remove unjustified single points of failure. If a component is critical, it needs a recovery story, an owner, and evidence that the story has been tested. A bank-grade AWS platform is not one product. It is an architecture where important failures have been anticipated, isolated, monitored, and rehearsed.